So is it getting recorded?
Yeah.
Okay, no, we can proceed now. So the first problem is like we need to reverse the letters. We are given a string S, and we need to return the reverse string where all the characters that are not in the letter stay in the same place and all the letters reverse their position. So like A, B, C, D, this will this space whatever I mean, and your space, that hyphen will remain as it is, and all the letters CD will be replaced by BA, and BA's position will be taken by CD. Like A and D, they'll swap their position, and B and C will swap their position. Yeah, and same goes here. I think. Yeah. Again, only letters will be interchanged here. Same thing for this. And yeah, S will contain only this, and these are the constraints for the string. So any queries in here or any approach?
So the letters are not case sensitive.
Yeah, they are
Oh, they
not
are
case
case
sensitive.
sensitive. Sorry, yeah.
I mean, sorry, case sensitive. Both larger and sorry, capital and small can be there.
Yeah. And
And we can have, other than English letters, we can have special characters, but they'll remain at the same place. Yeah.
This can be done in two-pointer approach.
Okay, how? I mean, can you explain?
Like we can start index from beginning of string and end of string. If it is letter, we
Yeah.
swap them. And if it is other character, then we from the left side we increment and right side we decrement the character.
I don't think. Have you implemented this way?
No, I have not.
Yeah, I think the two-pointer should work, right? Because what
should
is
work, but when this
uh-huh.
yeah, when the special character comes at that point, okay,
So
yeah,
you
go
just
ahead.
ignore them, because
Yeah,
yeah.
ignore an increment or decrement. If you're coming from left side, then increment. If you're coming from right side, then decrement the pointer.
Yeah.
Okay, because I was trying, I couldn't. That's why I
Oh,
thought
I have
somebody
that
else.
approach. Shashank, can I share?
Yeah, sure. Yeah, sure. Share it. Let me stop my sharing. Go ahead.
Can you see my screen?
Yeah.
So
So you're sharing the two-pointer approach, right?
right.
Okay.
This one.
Okay.
Yeah.
Okay.
So I'm starting from low, and then I'm going and I'm taking high as a string size -1. I'm just running the loop, and I'm checking that if it is not alphabet from the left side, then only increment the left value. Similarly, I'm checking that from the right, if it's not an alphabet, increment the right value, and then if both are alphabet, I'm just swapping.
Yeah.
Yeah.
And then increment. When you're swapping both of them, you increment
Yeah,
both of
just
them, right?
low plus and high minus. Yeah. So it will take care of both from the left side and right side when you have a special character.
Right.
Anyone have any question?
Yeah.
So what is the time complexity?
This length of the string only.
O of n, sorry.
Yeah.
O of S.
O of n, right?
O of string, length of string.
Length of the string, right?
Length of a string.
Length of the string.
And the space?
One, we go of one. We haven't used any another,
string or so, right? Yeah.
Yeah.
How do you swap without extra space? You may have to convert the string into an array or something. This is Python or what is this?
This is C++.
Okay, so how maybe C++ would have better handling over the strings, underlying data string.
Yeah,
Python
Java.
doesn't allow this way, like the swapping they are doing in string. No, like this we can't do in Python, like low with high. Yeah, only in array we can do the way you are doing swapping.
Yeah, in Java also you have to use a string builder, right?
Yeah, we can do string builder or string buffer.
Right.
Oh,
So every
An-
language has a different implementation. So I think Java will be like you'll have to have a space complexity of O of n.
Yep.
okay.
Maybe same with Python also.
yeah, I was
I
trying
did
with
it.
this. The problem was
Yeah.
okay.
Go ahead.
The
Go ahead.
problem was coming. The problem was coming over that swapping part. Like when I was doing in string, it's not allowed in Python. Like
You
case
can
of,
then
I mean,
use a third variable and swap, right? Put a temp and then put low there. Make high to low and then low to temp. I mean, just you can use a third variable to swap.
I have a sample if you guys want to take a look at that in Java that is doing swapping explicitly.
Okay.
Yeah, sure. I'm just
For
talking.
for C++, does it use the is the string reuse the same string or create a new one?
It's the same actually. In C++,
same.
the string is actually mutable.
Then
Yeah, string is mutable.
then we would modify the input, right?
Yeah, so actually underneath, they just have the wrapper around, but underneath they actually directly modify the row buffer.
But you are not passing the string as a reference, so you are not modifying the input too.
Yeah. Right.
Okay, let me know when
That
you
have to be
folks can see
returned a
the
new
screen.
string.
Can folks see the screen? I can
Yes.
quickly go through the explicit swap in Java.
Mhm.
So the approach remains the same. I just first converted the string into a character array and then took the pointers from start to end. While I see the character, rather non-character, I just increment the count so that whenever I reach to a position where both of them have characters, I'll go ahead and do the swap. So this is how I'm swapping. So I'm taking the using the extra variable to do the swap. And since it is a character array, the swapping doesn't need any locking or anything. You can just like swap like this. And after this, all the swaps, I will have my character array with corrected values and will just form a string out of that again to return the expected output.
Yeah, I think this is what expected here in this question, that how do you actually do the in place. So yeah, in Java, so you cannot directly modify the string, but if you just convert it to the char array and then do the in place.
So yeah, there is an extra space here, which I don't know the implementation details of this to-char array, like how time consuming would that be? I would guess it would be order of n and order of n space as well.
Yes.
Yeah.
So this one, the implementation is almost the same. I mean, the same as the previous one. And, I just wonder the style in here, we have the, nested while loop, versus the previous one, we have if, which one you guys prefer?
Nested while is talking, right?
No, but
Both
both are
of
the
them
same,
are
right? The results are the same.
The previous one, it like, it only if statement and it continue, right? It treat the each iteration, independently. And this one will have like, nested while loop inside a while loop.
So in case of like nested while loop, when you have a multiple non-alphabetical characters, so you'll skip them in a continuous manner. So you'll skip them all together. Otherwise, in the
But
previous solution,
I'm
we'll
asking
just
about the style. We
okay,
would
the
prefer to
coding.
use the if or
Yeah.
while here.
So even in this one, I mean, I do see an issue that if let's say one while loop break with the condition and start or start end, and still we are actually executing the if block. Is not that an issue?
It will, anyways.
Because he already checked the condition at the beginning of the while loop, right? For each
No, but
while
No,
loop.
but then inside I'm
when you
increasing and decreasing.
entered in that the first while loop, and then you are modifying the value of start and end, and you break from the loop, and you break with that the first condition in that loop.
Yep. So this will take care of the, I think what you're talking about is going out of bounds for maybe end going to less than 0 or start going to more than length. This condition will take care of it. So in this if condition, I am
Yeah.
safe for the values of start and end.
No, but when you are checking here, so you already actually cross the start and end.
Yeah, even though I cross the start and end, so here is the thing, right? It will only execute till end is greater than or equal to. So the worst case scenario will be end will be equal to start at
Yeah.
this line.
Okay.
That is still within the array bounds.
Mm-hmm.
Yeah, I think so. This should be okay. So the question Leon was raising, actually, the style depends on person to person, I would say.
Yeah.
Yeah, so
Yeah.
both are good. And
I think whatever you find more intuitive, right? So when you are talking, you would, so if you are trying to solve this question, right, what you will say is that, okay, I'll try to find the first character which I can swap from the left end and from the right end. So it's basically putting those statements into the code. So I'm trying to find the first character I can swap from left, trying to find the first character from the right, and then swapping them. If that is not something which is intuitive to you, then you can go ahead with the other style, which is like use the external, the outer while loop to just iterate and maybe skip inside if you see the non-character.
yep.
Another way we can approach is using stacks.
Yeah, I would like to see the stack approach if someone
Yeah, I
has.
have implemented that too.
Go for it.
Yeah. So yeah. So what I'm doing, I'm running this first loop. I'm checking if this is the alphabet. Then I'm putting that in a stack, all the alphabets. Okay. Second time, what I am doing, I have taken another string as string, uh, which will return as an answer. I'm again running through the loop and I'm checking that if it's not a alphabet, then I'm putting the special character, pushing the in the string. Else, I am pushing the stack value from the stack.
This stack list one like normal array you are taking as extra space, right? Namesake is stack.
Yeah,
I mean,
STK, that is the stack. Yeah.
Where does swap happen? This
So
question
let's suppose. Okay.
we give an
So he's
example.
using a stack, right? So that
yeah,
itself he is actually reversing the whole thing.
exactly.
Yeah, I
So
can give you example.
no need of swapping.
Yeah.
That is
So
advantage over here.
when you have this AB/CD, so in the stack content will be ABCD. D will be on the top.
You are not sharing the screen. What you are actually
Uh,
you are
yeah,
looking. Oh, you are on the same screen. Okay, I thought you
yeah,
were showing
yeah.
something on a whiteboard.
Wait, let me edit this code. Yeah. So let's take the first example only. So we have this example. So once the stack contain will be something like this: A, B, C, and D. Okay. Yeah. So now when we enter this loop, right? We go on check this. We go on check the string that what is the content of the string. The first character A is alphabet. So we pop D from the string, from the stack, and push it in a string of this answer. Next, we check for the B, it's also alphabet C. Now we come here and we check for this non-alphabet. So the dash is an odd alphabet. So we push in the string this dash and we move forward, and then we do B and then we do it. So so we require a stack as a size will complexity will be big of n in the worst case, like if all alphabets are there, no special characters. So yeah.
Where is the implementation for push_back?
This implementation I didn't get you. Can you come again?
Yeah, that function method, where is it implemented?
That is a standard STL function.
Yeah, it's a
So,
string
yeah.
in the string library. We
Okay.
get.
So vector actually, yeah, vector.
Yeah.
Yeah, so in stack also we can do.
So in this case, only the slightly different about the previous approaches, you are iterating twice.
Right.
Right, yeah.
Yeah, and space
So
is
it's like
even.
O2 of n, something like that, but yeah, it doesn't
Yeah,
matter.
space will also increase. Big of length of string in the worst case.
But two pointer was more optimal, right?
Yes.
Yeah. Yes.
But time complexity wise, both come same, as well as
Yeah.
space complexity wise, right?
No, space we are
Not,
using a
not
stack.
space.
Yeah, space in terms of C++, slightly okay, fine. But if you go for Java, actually it is the same.
I'm also like, I mean, asymptotically they are same, but 2 times is iterating. I mean, if we go precisely, like practically if you go, and there
True.
only once he'll have. So that would be, I think, again better than.
Yeah, slightly, yeah, better, yeah, okay.
Yeah.
Makes sense.
The other one we do only half, right? We're not like kind of y low less
Exactly.
than high. We only do
Yeah,
half
it's
of it.
actually n/2, yeah.
Yeah.
Oh yeah, yeah, you're right.
Right.
That's much better. Yeah, I'm sorry, I missed that. Okay.
Yeah.
Let's move to the next one.
So mine is same what Saurabh was using. He took stack, I took a list. I'll first check if all the characters, his alpha will contain both English plus this, and I'll append all those characters. Took extra empty string I'll take, and I'll enumerate it. The moment I find it is a English character, bigger or smaller, I'll append. I'll pop it from the letter and append to this, else I'll attach that. If it is extra, symbol which is other than the English alphabet, then you append it directly.
So here the letters is like a DQ?
No, normal list.
It's a normal list, okay.
Yeah.
So you can access from both ends?
Yeah.
Okay.
Your letters will have. This, all the letters will get in a list like this.
Yeah, in Python, I think queue and stack are implemented in the list itself. That array itself, yeah.
In Python, stack, queue, or normal list seems to be all implemented in form of a list only.
What about this string handling? How does Python handle? I think in Java it creates a new string every time you update it. What about Python?
Python, I tried to do that first 2-pointer approach, but I was getting stuck at that point when I was trying to reverse like s of start, like it would have reverses s of start.
No, not really that. Like, is there?
Strings are immutable.
So what I was asking was that. Yeah, so I think in Python also. Yeah, in Python also they might be immutable. So is there like a concept of string buffer or something in Python?
like the string builder?
No, I don't think so. No, as of
We
now, I
can
haven't come across.
we can convert the string to list and swap, right?
I don't think so. String that concept is there in Python.
Like if you call list of string, that will create a list of each character as a list of characters of that string. If suppose if you give letters equal to list of s, then it will create a list of each characters of s as a list. Then you can swap them as you want, and you can join them.
It's a different way. Okay.
I don't know. I haven't come across. Maybe there might be, but I'm not sure.
Yeah.
So that way I will share.
Yeah, sure. Share it. Okay. Are you sharing?
Yeah, one second. Yeah, like
Some voice, extra voice is coming.
one second.
Yeah, now it's clear.
Hello.
Yeah, now it's clear.
Yeah, okay. So I'm just trying to do this. So if you give s to as a list, you convert that string into a list of characters.
Mm-hmm.
Like, then like you can swap it as you want.
Directly within string we can't do. We have to convert it to list and then we can use the swap that one, right?
Yeah.
Okay. Yeah. Yeah, that might. Okay.
Yep. Okay.
Yeah, we can
Next
proceed
one.
to next.
Yeah.
This is the advantage shuffle. We are given two arrays A and B of equal size. The advantage of A with respect to B is the number of indices I for which A of I is greater than B of I. We need to return any of the permutation of it that maximizes its advantage with respect to B. So here A array is given. So they are telling any permutation of it. So there are 4 different elements. So we can have 24 possible arrangements for this array, out of which this is one that particular array in which you will find that every element of this is bigger than their corresponding B element. 2 is greater than 1, 11 is greater than 10, 7 is greater than 4, and 15 is greater than 11. Had we taken some other permutation, you won't get 4 as a count. So that's why we have selected this array. Next, again, you go for this. Again, you'll have 24 permutations for this because all the numbers are different, out of which this array will give you the maximum count in which the element of A will be bigger than their corresponding element in B. Like 24 is greater than 3, one element, then 32 is again greater than 25, but 8 is less than 32, but again 12 is greater than 11. So count corresponding to this is 3. If you'd have taken some other array, then in that case you might not have got 3. That's why we are choosing this array as an answer. And this is the constraint, like a length, array length of A's array length and B's array length should be less than 110k, and A of I is less than equal to 10 raised to power 9, and B of I same. Yeah, any queries in the question or approaches? Font size, yeah.
And
So,
Pardon, I
yes,
think.
and yes, Santosh should also say. So I was saying about using the greedy approach.
Yeah.
Like we can iterate through A It means we can, in outer loop, we can iterate through and we can find the closest element in A that is just bigger than B, that bi. So
Okay.
accordingly, we can start building the output array. Like
You
for
want to
example,
share?
like
Mm.
okay, I'll just write it in the notepad.
Share it. It will be better if you share it.
So yeah, actually, before he's
Yeah, you can.
explaining it,
Yeah.
yeah, what I was, on the problem statement, the shuffle is the one what we do on the array A, right? So that is what the word
Yeah.
shuffle comes here, right?
Yeah.
Yes.
Exactly. Huh.
So you shuffle it in such a way that you get advantage from that A array, and that will be your answer.
Maximum element of count you should generate. Like maximum element of array should be greater than B. That array we have to pick.
Yes.
So I was thinking about like a shuffle in the sense the card, what we have those card games, you shuffle, but it's not like that, because if you look at the node, it says like so many cards, like 10,000. It's not possible, right?
Yeah.
So,
Yeah. Exactly.
yeah.
So my intuition was actually exactly based on the card. So like see, like we all are playing the playing card, right? And we have some cards in our hand, and let's say Santosh put 6, and now I know that we just only Santosh and myself are playing, right? Santosh put 6. So what should I put here to satisfy the condition?
Kind of insertion sort of what, like.
Yeah. So I should just put the the biggest card, and which is my lowest card. The biggest lowest card. The biggest lowest card. That's it. And if I play with that strategy, so that will give me the optimal.
Yeah, it's a similar problem, but on a large scale, I would say, because you won't have such a big cards.
Yes.
But we are just playing with the numbers here.
So you're trying to put the external card at its correct position, right? I mean, at a position which is lower than the.
Yeah.
Like, let's say you have a card from 1 to 5. Okay, yeah.
So like I'm not sure whether it would work or not, but this is my intuition. So for every element in B, we'll try to figure out the smallest largest element, then Bi. For like for B0 for 1, we'll see the just greater element than 1 is 2 in the array A. So that we can pick in our answer. Then we can look for the first element in the array B, that is 10. The next greater element than this is 11 in A. Similarly for 2, and then for this, so we'll get 7, 15. And we'll also need to, I think, mark which element we have picked in A, so that we don't pick it again.
Yeah.
So this would be n square.
Exactly.
Yeah.
Your approach will perfectly I mean, get that, but that will be n square actually.
Yeah. So anything better than this? I'll just stop sharing.
No, one thing. Why it will be n square?
Because
for every element in B, you have to go through the entire array in A. To decide that I have to pick 2 for the element 1 in B, I need to go through the entire array of A.
Yeah. So what you are saying, if you can sort the array, you can reduce the time, right?
Yeah, something like that.
You can use binary search on the top. Yeah. That will be improvisation.
Yeah. If we can sort the array, then we can do binary search.
Yeah, sort the array and just find the seal.
Yeah. So it would be n log n.
After that, you have to remove that also, whatever element you are taking.
Yes.
Yeah.
Yeah, or like we can mark and have like use extra space to mark that like this element has been already, we cannot reuse.
So greedy and brute force both became same only, right? In brute force also, what you will take element of B's first element, you will check its correct position.
One of the brute force is like you can generate all the combinations of A and C.
That's worst brute force.
Yeah.
No, brute force is like
But
worst
at least you
only.
have a solution there, right? Yeah,
Yeah,
that's
yeah,
true.
exactly.
So
Yeah.
I have done this using multiset in C++.
Oh, share it.
So should I like stop sharing and other people can share their approaches?
Sure.
Uh,
Yeah,
Or
yeah, sure.
anyone wants to discuss this approach,
No,
anything?
I
what?
kind of yeah.
Okay,
So I did the same approach. Uh, what you did, like I sorted AI in for every D element I in the seal, and there was a test case that was failing for that. Like it is not giving me the maximum.
So
can you share that test case, because even I'm not fully sure, like mathematically the greedy approach
Like
give you.
no, that will work. Are you handling the duplicate?
yeah, I'm handling the duplicate.
Because the array may have duplicate.
Yeah, it has
I
duplicates.
think I
Yeah.
shared in the.
Handle that. I shared it in chart. Can you try to
Yeah, yeah,
list it?
sure.
Should I stop sharing?
No, continue.
So like we
After
can
that, he'll
go
share.
through this
So
input and see why it is failing.
I'm using this as a multiset. So what multiset does, right? It will sort in the ascending order, the array A. Now what I'm doing, as mentioned, that I'm just checking the seal value, upper bound of the bi element b1. So let's suppose we have this 1. So I'm taking this as an input and checking in the set, which I have formed using a array, that give me a number which is just strictly greater than 1, the first value. So it will give me 2, and this condition is to check that if something is existing there or not. Okay, so if it's existing, then we will set this value, that will in the output we have in the output we'll take 2. If it's not existing, then we have to take the least value from the a array. Like let's suppose for uh, this example, okay, we don't have example such here, but in B, if we have 16, so something, there's nothing greater than uh, 16 in array A. So what you have to do, you have to take the least element from array A which is left. Any questions on this?
Can you take an example? Maybe just create some example or whatever you shared just now with
I think second example
the
will
chat.
fit for that.
Okay. So
Open chat.
so in this, if you are putting the array into the set, right? So it will come like this. The multi-set will be like this. Okay. Now what we are doing, we are going and seeing in B that give me a value from A which is strictly greater than this value. So for 13 we got 24, right? And now the 24 is removed. For 25 we got 32, which is
30.
strictly greater.
Yeah.
Yeah. So I'll just remove this. So for we got 32 here. Now it got removed. Right. Now in B we got 32 here, right? Since there is no element in no element in A which is greater than 32. So we are taking the first element from the array A. So we got 8 here. Next for 12. So we for 11 we are getting 12. So we wrote 12. So this is how the array is formed. The output is coming.
So which is the place where you in the code where you look for the lowest one when you don't find a match?
So here, so if p is not equal to set dot end, so we are direct.
Okay.
Yeah.
Okay. If you don't find it, then you go and get the latest
Yeah.
one,
Yeah.
smallest one.
No, I mean
Big
if you don't find it, then we do here set dot begin.
Oh, the
We
second.
do it here.
Okay.
Yeah.
But
If
set will never have the element in a proper order, right? It can have in any orientation,
no,
won't
this
be
is a multi-set.
increase.
So this is a
Oh,
multi-set.
okay.
It
Yes.
shorts
So
in yeah.
in C++, sat and map are actually sorted based on the tree. These are the tree-based
So
implementation.
this, yeah, red black tree based implementation.
Okay.
Balanced
Yeah.
financial trees. If we give this a
That's the
greater int, yeah, if you give a greater int in the multiset, so it will sort in the descending order.
So set and multiset differ by orientation only, right?
No, sat and multisat, the only difference is that sat does not allow the duplicate and multisat allow you to duplicate.
Yeah, correct.
So like what are the, how much does the erase and
Log n.
Log n.
Yeah. And upper bound would also cost log n. So
Yeah,
it's also n log n.
Yes.
Right. Insertion will take one big O of 1, and your deletion, your searching and all will take big O of log n.
Okay. Yeah, so
Insertion will be log n, right?
Insert will also take log n, yes.
Yeah.
But creating that sat is actually n log n.
Yeah, so it's also n log n. So I think in Java we can use tree map as an equivalent.
Yes.
That will also, I think, will take n log n only, right?
Yeah, because I think the underlying approach is a similar one to the sorting and then doing the greedy thing. We're always like picking, that is also doing binary search, but we will do by ourselves. We're just using library. But with set like erasing and all those, otherwise you'll have to keep extra arrays and map or something, maintain whether you like you used that element previously, so you can't.
Yeah.
No.
Any further questions?
So in this approach, the time complexity, the best you can do is n log n.
Yeah, right.
That's what is the conclusion. With a space complexity of O of n.
Yes.
Any approach lesser than this? I mean, in terms of time complexity?
I don't know if we can do this on DP or not, but I might try. I don't know, because this is similar to like a 0-1 knapsack. You have to take one value or don't take one value. But I'm not sure if that is perfectly. I'm thinking in that way. I mean, just a thought.
Yeah, if we can do, then definitely that will be the complexity will be more than that because the array is not sorted.
Yeah, if you say knapsack, it should be O of n square, right?
Right. Yeah.
Even like that, you said that we can take an element or we cannot, but like then fit that thing.
You have to verify for all the elements.
Yeah.
I think.
So this is the best end. Okay.
Yeah. Yeah, corresponding to that, we have in Python bisect. This approach is same only. Just it will check when you give, let's you take any element from B, it will check which is the next element which is greater than this. So for 1 you'll have 2, for 10 you can get 11, again for 4 you'll get 7 because that is the next immediate which is greater than this. So same thing, approach is same only, just as a matter of language. And just we are checking if that index crosses your boundary, then you initialize it to 0, else you append it and then delete that particular element from the array. No. Yeah, we can. So any queries?
Why do you have to? Yeah, Shashank, why did you
Carry on.
sorted it then? You sorted the A, right?
How will you, because binary search we can use only on sorted array, right? That advantage. This is like kind of binary bisect.
Yeah. Okay.
So one thing I was wondering, it just came to my mind. Can't we use monotonic stack here? Maybe, but I don't think so, right? Because you won't be able to find the right combination.
Yeah, that will.
Yeah. It
So
will have the
still have to
same.
sort.
Yeah, it will have the same issue that I mean, it might be possible that when you are actually putting an element in A or placing assuming that is the correct element for this position, but it might be possible that there may be a smaller element exist after that, and which is also possible for this position.
Yeah. So you'll have to sort it.
Stack will use either increasing or decreasing only. So for that we have to sort it only, right?
Yeah.
So again, everything boils down to sorting at last.
Absolutely. So it at least is n log n. Yeah.
Yeah. Okay.
No problem.
We can proceed to next. It's a K-Concatenation Maximum Sum. We are given an integer array and an integer K. We need to modify the array by repeating it K times. For example, we have an array 1 and 2. 3 times they'll repeat 1, 2, 1, 2, 1, 2. And we need to return the maximum sub-array sum in the modified array. Note that length of the sub-array can be 0 and its sum is, in that case, is 0. Answer could be large, so you need to take the modulo with this. So just repeated k equal to 3 and they got the max sum array is 9, and for this 2 and so on. And this is the limitation is like array length will be less than 10 to the 5 k, again 10 to the 5, and the element will be from this to this. Yeah, any queries in this rough process?
So you have negative numbers also in this.
Yeah, that makes this problem a bit difficult. I mean, not difficult, but out of box.
Yeah, the array size itself is really huge, and the range of the numbers are really huge.
And then he's asking us to actually keep on concatenating.
Yeah, and k value also value also very huge. So they are actually showing intention that you cannot actually build that array in memory.
Oh yeah.
That's the underlying motive.
But you should be able to do it in Java, right? Because Java allows. Not in memory. You'll have to store it. In second.
So think about that. 10 to the power 5 is the length, and k is equal to 10 to the power 5. So that will be really huge.
Yeah, so it will be, if you are concatenating, it means we are adding, right? So it will be 2 multiplied by 10 raised to 5, right? If we consider the maximum one. Okay, so if that's the limitation, then yeah, we're done.
So if, let's say, suppose we have this array and we find the max sum is somewhere, in the middle of the array, then if we concatenate them, then we wouldn't get the better answer, right?
We may get the better answer if the prefix and suffix sum is greater than the sum of the you find in the middle.
So individually it could be smaller. Oh yeah.
Yeah,
but
you see, you can see example 2. So that will give you an idea. So if you see the individual answer is 1, but when you concatenate that, so the prefix for the first array and the suffix for the second. So my bad. Sorry, suffix for the first one and prefix for the second one will give you the better answer.
But in this case, sorry. But in this case, the example 2 you're talking about, right? The middle one is smaller than the prefix and the suffix. If let's say if the middle one is bigger than the prefix and suffix, then would that be the best answer we can get, regardless of if we concatenate them?
Yeah, we might take an example and check.
Yeah, we can concatenate and see.
So
Is it safe to
he's
assume
saying,
that
you know,
if
like,
sorry,
Yeah.
sorry.
so Leon is saying, like, you know, if you find the answer of the biggest sum in the middle, where both ends are actually maybe negative numbers, then actually that will be the answer, right?
No, let's take an example. So let's say
Okay.
2 minus 2.
Yeah, we can.
Yeah, who is sharing the screen? Yeah.
If somebody wants to share the screen?
Oh, you can type because I have not actually implemented that. So you can just type, and we are just actually trying to run on that example. So 2 minus 2.
Your 2.
2 minus 2.
Mm-hmm.
1, 3. Minus 4. 3.
Okay.
Yeah, so the middle answer is, so here in we know that the middle is 4, right? So answer should be 4, right?
Right. Yeah.
1 and 3.
See.
And when we actually concatenate these two, so the prefix sum is 2 and suffix is 3. So the answer should be 5 if k is 2.
Yeah. So will at least have to do one concatenation to get the optimum answer.
You don't need to actually. If somehow we actually find a way to get the prefix sum,
okay.
And we think like that. I'm thinking. Let's say if it's a connected from the back, right? It's circular.
Mm-hmm. Okay.
Yeah.
Yeah.
What is the answer for this one?
5.
If we have to run the we just want the answer for the single array, then it should be 4. But if say if we go with this question and k is 2, then answer will be 5.
No, this one is not 4. I think it's 3.
3.
1 and 3. No, 1 and 3.
0, 1, 2.
The maximum.
Maximum will be 4, right?
Yeah, but it cancels. Oh, you mean like? Oh, got it. Not like. All right.
So you use the
maximum
algorithm, right? Yeah. The contiguous maximum algorithm.
Yeah.
It look like if we concatenate them, look like a divide and conquer algorithm, right?
That look like, but we cannot actually really concatenate. We have to actually that on fly without doing that, considering the constraint of the memory.
Yeah, I just want to mention k equal to 2, right? There is another question in lead code which is maximum sum circular array, right? So in that question we have to find the maximum sum array considering it is a circular array.
Yeah,
so if you can open,
so
that's the prerequisite of this question maybe. That once. So I was trying to solve that question. Maximum sum circular array.
Yeah, I think so. Yeah, that might be.
Oh, max. Oh, this one.
Yeah, 918. Yeah, right.
So in this case, it's considered only 2.
Right. Yeah.
2. Yeah. Okay.
So if you see the examples there, I think the second example, if you come, 5 minus 3, 5. So if we go on with the k equal to 1, right, 5 to 7 should be the answer. But if you take it as a circular array, then first and the last will be answer 10. That's what we are discussing.
Okay.
Right. Yeah.
We have to somehow use using k equal to 2. Once we get that, then every k is a repetitive of this. I mean, It's just like a chain. So we might get some relation out of that.
Yep.
Yeah.
I think Martino had some question, right? Sorry, just went in different.
No, Santosh, I just, I think it was already answered. I forgot
Okay.
really.
No problem. Yes, okay.
I have an idea here, like I have implemented this. So my instinct was, okay.
Share it down.
Yeah, hold on.
Oh, okay, it came to me. Okay, so for if they're all positive, then it's safe to assume that the whole array times the k is gonna be the answer, correct?
Yeah.
Yes.
Yeah.
Okay.
Yeah. In that case, I think you just find
I think the
the
first
sum of the whole
example.
array and multiply it by k.
Yeah.
Got it. Okay.
The first example, exactly.
Okay. So my intuition here was that if k is equal to 1, then we know that it is the question of maximum subarray, right? If k is equal to 2, then maybe that circular one, or in k equal to 2 case, we always think about the both the ends. In this question, we need to think about both the ends, that what is as someone was mentioning, the prefix sum and the suffix sum. So if k is equal to 2, then I am just clubbing these two arrays together. So 1 minus 2, 1, 1 minus 2, 1 together. So there is an opportunity for me to get bigger than the maximum subarray. So 1 minus 2, 1. And then if I put 1 minus 2, 1.
Can you scroll it up?
Boomer, can you increase your font size a bit, if
Yeah.
possible?
I think he got freezed.
Yeah, we lost him, it seems.
Yeah, thanks. Yeah, he's not in the.
Yeah, he'll come back. Yeah.
Okay.
Okay. In the meantime, Shashank, you can actually.
Yeah. I use the same concept, like we have this prefix sum, like at every point, like till this point, what you're saying, the max sum is 2, right? Now, while going to the next, like first to repeat all the elements, like 3 times whatever they're saying, 1 2 1 2 1 2, do that. After that, what I'll do, at every index we'll check whether by including that element we can get the max sum, or by taking that ith element we can get the max sum. So this is what a standard algorithm called Kadane's algorithm is there. Like in this case, like see at this place we can get a, initially the prefix sum is 2. Now when we reach at the index -2, there if you take the previous element, then it will be 0, and if you take only -2, it will be -2. So maximum of these two will be what? 0.
Yeah.
Same way we'll go to 1. Now simply 1, if you take, it will be 1, and if you club all the previous whatever you have taken, that is 0 plus 1. So here both will be same. So max will be here 1. Again, so on will proceed for the further. Like if you take here 3, then if you take only 3, then 1 is 3, and the other possibility is like 3 plus 4, 4 minus 2 is 2, and 2 plus 2 is 4. So it's better to include all of them, and the maximum till this point will be 4.
Yeah.
And yeah, same. So I mean, from backside, I'll like kind of DP approach. It is based on DP only. Like every index will check whether that particular element is maximum, or by adding the previous elements with this particular element, will that be maximum? We'll store their indexes over there.
It's always have to include from index 0. right?
Yeah. Yeah, index. No, you can take from here only because already you have calculated till here the maximum sum, right? You already
Yes,
know
right.
once you reach
But
at 3.
the prefix sums always include the index 0.
I didn't get what are you saying?
So the that value would be the range from that index to 0, right? The whole range. It's not like
Yep,
it's not a
it should not
substring.
drop any elements from the beginning. That's the condition. Yeah.
Yeah.
I think Shashank, you're explaining Cardano's algorithm, or you're taking the prefix sum?
Yeah, that's Cardano's algorithm only.
Yeah, so in this case, it is coming as a prefix sum also, but he's actually explaining the algorithm. Find the maximum sums of array.
Vomik, if you are back, then you can share.
Yeah, you can share it.
Guys, if this Shashank, when you build this, it's based on the cadence algorithm, cadence or whatever.
Yeah, exactly. Yeah, it's based on Cardano's algorithm.
Got it. So in this case, like let's say if k is 5, then the sum will still be like the maximum will still be 5 in this case, correct? No, 4. I'm sorry, 4.
Yeah.
For the next iteration,
Do you think that if this array comes up to be like a sorted, I mean increasing array, then we have to multiply by 3, or no? I mean by k.
I mean you are first calculating maximum sum on the original array and then multiplying by 3. That sum. Is that what you're saying?
No.
We'll
So
calculate max.
in this case, we don't multiply by any k, correct? Because it's not.
No.
If we don't, right?
Yeah, no. We first expand it to the given k, and then we use this Cardano's algorithm to find the maximum sum.
Okay, so first we expand it, you're saying?
Yeah.
But what about the discussion before about the memory?
He's not concatenating, right? Are you
I think
concatenating?
there will be three cases.
Yeah, 3 cases. Okay.
Yeah, 3 scenarios. One is that you get the maximum sum, and that include all the elements of the array, right? So in that case, you will have to multiply by k.
Okay. And there is another case, I think. I mean, let's say just like Shashank was doing with this algorithm. Let's say if this resulting on line 27, if this array was like 2, 3, 4, 7, 10, then we can multiply by k as well. No?
Even like,
let's say 2, I don't know, 2, 3,
4. So that is the input array you are telling that?
No. That's gonna be the one after you do the maximum sum.
Okay. Yeah. So definitely, because here you are including all the elements from the input array, right?
Yeah. Okay.
Yeah, I believe
that's
that in
when you
that
multiply
case.
by k. Okay.
Yes.
Okay, got it.
Can we just go to this algorithm first, see how it works?
Yeah, sure. So first you add 2, right? After that, this minus 2, and you add this plus 2. 0 and minus 2. The bigger will be 0. Then you'll have 1. Either you can take 1 or you club all this. So what it will be? 1 only, I think. Minus 2 minus 2 0. 0 plus 1, and 1 and 1, it will be 1 only. And if you come here at 3, either you'll have 3 or 3 1 4. 4 to 6 minus 2 4. So 4 will be the max. And if this is either minus 4 or this is I mean you minus 4 or 0, it will be 0, I think, max. Actually you have to store the indices at this place. I'm storing the result, and here if you come 3, and till now you have the maximum sum as 0, so bigger between these two is 3, so 3 will be the 3 will be the maximum sum till here.
Okay.
Yeah. So we don't need to store this sum. Just take a variable and just store the indices. At every indices, you check which one, either by including that element or by the sum of the previous elements, which one is bigger. You have to take care of the indices in this case.
Take a global value and check between every time the max you are getting with one global, and that will be a
Okay, then what we do next?
Next, once you get, wait, I'll show you. So you iterated through, you are iterating through all the elements of the array. This is what I was telling you. You'll check at every step what is your max. If your maximum is less than 0, you make it initialize to 0 and check for the at every step check till the maximum so far and to the current element how much you are getting. You send this, you will return this max so far to this, and these are the base conditions. Just check if you have only 2 elements, whatever they have returned you the maximum till here. You do the sum of all the array. Okay, now you check if that is less than 2, then only 2 elements. If you have, just go for this. If you have the sum is greater than 0, you check for the previous sum, unless whatever k is given to you, like k3, or if 3 is given, you check it for.
Hello.
Yeah, I think we lost Sashank.
Yeah. Am I audible?
Yeah, you are audible.
This one will repeat 3. Every time you do for one pass, second and third.
Yeah, and you are using that modulo there.
For the returning the
value. Okay.
Oh, what is this line 9? Line number 9.
So once you get that max, once you pass, initially what you'll do, you'll pass the normal array, right? K is given as 3. So 3 times you need to do that operation.
Yeah.
K equal to, so first we'll pass the original array. Normal array as it is what you pass. Now if you check if K is less than 2, that means you don't need to do anything. Only one time it will calculate the maximum and return the result. But if it is greater than 2, then in that case, for each time you have to do. First time for 3 it will pass, then 2 it will pass, and 1.
I think you have, like, for example,
Yeah.
you haven't calculated the prefix and suffix. You're adding.
This is taking care of that. Yeah.
It looks like that.
Storing the.
Yeah, the simple approach to understand would be like, you can, in case when the total sum is greater than 0, you can take the maximum of the prefix sum, maximum of the suffix sum, plus k minus 2 into the total. Does it make more sense rather than the equation that Shashank has written?
Can you explain once more, like in a written form?
So can I share my screen?
Sure.
So let's take an example of minus. So let's say this is my array, and my k is suppose 5. So this would be my all the concatenations of the array A1, A2, A3, and A5. So the total sum would be of this is it's 7. So for this part, since the sum is greater than 0, we can always include these 3 arrays to be included in our final sum. Because the sum is 0, it would always have a positive contribution to the final answer. So we can take 21 directly. For A1, we should calculate the suffix sum. We should start going
So here
from
it is
back.
8, right? The sum should be 8, right?
Yeah, I might have done some wrong
Okay.
calculation.
Sorry.
Yeah. So see, so for which part we have to take for A1, we can take the entire A1, but that won't give us the maximum sum. We can just start going from behind and see like 5. We can start calculating the suffix sum. So it would be 5, then it would be 3, then it would be 6, then it would be 8, and then it would be 7. So I think final sum is 7. Am I correct?
Yeah, it's 7.
Yeah. So the maximum prefix would be, so we can include the A1 to be till this point. So we can write it like this. And similarly, for the part in A5, the last array, we can start iterating from here and start calculating the prefix sum. So it would be, so you all are getting the idea what I'm trying to do. It would be -1 in the starting, 1, 4, 2, and 7. So prefix sum would be, maximum prefix sum would be 7. So this would remain our final answer. So it converts to a formula of maximum of the suffix plus k minus plus k minus 2 into the sum of array plus max of the prefix sum. But only in the case when sum is greater than 0. If sum is negative, so then there's no point considering these arrays. So what we can do is, so I should have an example 2 also. So let's say -1, -2, 1, minus. So the sum is, so in this case, we can either take, I think, we can take
In this case, we
prefix
should go for
plus,
maximum sub-array. No.
no. I
In
think that
case
would,
of sum less than 0, we should go with maximum sub-array because if we
yeah, I
include
think
the middle ones
you
as
can,
well. Yeah.
you can take the maximum of these 2 maybe. I'm just thinking it looks like that. So it is also possible like we can have a combination of like, if suppose here also k is 5 or any number greater than 2, so we can have a combination of prefix and suffix. So let's just calculate the prefix sum, and that would be -1, -3, 1, 2, and -2. So prefix would give us the maximum sum to be 2, and maximum suffix would be -4, and that would give us -1. So it would be -3, -1, and it's just getting negative. So we cannot actually combine here the prefix and suffix because, so prefix and suffix would give us the maximum of 1, and if you use Cardane, then you can use just 3. So using Cardanes mean we are just taking the one instance of the array. We are not including any other elements, but it might be possible that we can use 2 we can use elements from two parts of the array, some from the prefix and some from the suffix of the array to combine. That might also give us the answer.
What if the sum equals 0?
Yeah, if sum equals 0, then it doesn't make any sense. This part won't have any contribution to the array. Then we'll just come to, I think, this part. Can we have any prefix plus suffix combination that might give us a bigger answer, or then we can look into just a single array using Kardashev algorithm and see what is the maximum sums of array.
Yeah, that makes
Just
sense.
a quick comment. So the example 2 for sum less than 0, whatever you have done is the maximum of prefix plus suffix and Kadane. I think that is more applicable when sum is
I
equal
feel
to
that
0.
yeah, it is possible. Then this might also give us an answer. Here
Yeah,
in this
but
case, this part is giving us the correct answer. But it might be possible that this part might also give us an answer. Where
you
we
can't
have a
take something in the middle if the sum is less than 0. If you have k equal to 5 and
we can we
the
can
total
always.
is...
So what I'm doing when I'm taking prefix plus suffix is I'm taking when I'm combining the two arrays A1 and A2 and trying to find if there is some maximum sum. We can make a test case where that might give us a better result than Kadane. I'll just try to put that. Suppose if I make this -1 and make this 4, yeah, just rewrite it. Okay. The sum still less is negative yet. No, it is without positive, so you can have this thing. Now it is still negative, -4. So when we calculate the prefix sum, it will start with -5, go to -7, 5,
-5.
4, and then it would become 0. So let's make it 6 and make it -4.
It is -5, right? Like
Yeah,
-5, 7, and then -5.
Yeah. Oh, sorry. So it's -5. So I don't think this will also make it 0. But it might be possible. I'm just having a gut feeling. We might get a case where this might give us an answer. Or like we can code and see that always this is giving a right answer.
Yeah. Maybe if you have a code, could post
Yeah,
it
we
in
can.
Slack, and then we can discuss about that. Yeah.
Yeah.
No wrong. Yeah. Thank you.
Thank you.
Oh, yeah. Thanks. I did not get the formula that he shared. Yeah. I did not get how that makes sense into the proposal.
So, Shashank, you implement a little bit different, right? Because I see on line number 9, you have the array times 2. Would that extend the array size?
Yeah, that will expand the array size.
But would that affect the memory because we keep going up?
Regarding memory, definitely it will affect. Maybe regarding memory, I can't say. You're telling that it will, I mean, once more, can you go?
And you, on your code on line number 9, if somebody was asking and I looked at it, it was like you do the kind of recursive with array time 2.
Yeah.
You just share your screen first, Shashank.
Oh, I haven't shared it. Sorry.
So are you really allocating the array, increasing the size, or just actually doing on fly and assuming that repeating that array on the same array?
On the same array, I'm repeating. I'm expanding that. It's the same array. Okay. Wait, I think wrong screen I'm sharing. Is it visible?
Yep.
Yeah. Yeah, which this one.
Yeah, so max subarray. So you are in, so what it does that array star to? What it does in
It
fact?
will double.
It will double means double the values inside the array.
No, 1 to 1 to repetition.
Concatenate it like that.
Okay. So that means it's allocating the.
Yeah, it's not like 2 4. It will not make 1 2 as 2 4. 1 2 again 1 2 2. But there is some flaw in this solution. It's not getting executed correctly. It's only a rough idea I've given.
Oh, so not submitted yet, right?
No, yeah, it was giving some error.
In what case do you do this with doubling the array?
Like one time you pardon, I didn't get what?
I'm saying like well, what is this, the stitch cadence? Why does it duplicate the array? I mean, why does it double?
It's actually duplicating the array to handle the scenario what Jasima just explained that to get the prefix and suffix. So instead of that, he's actually making this duplicate array and running the algorithm to get the maximum subarray sum.
Okay.
Yeah.
Got it.
So as you have not submitted yet, so we are not sure whether on that there will be any memory issue or not.
I'll check it and then I'll post on the Slack. Some issues are there.
Yeah, please share if you submit and lead code accept it.
Okay, sure.
Actually, if you concatenate only 2 of them and run a cadence algorithm on it, and then you do all those changes to that if it's more than 2, right? So then it should work, right?
Oh, but Santosh, still, if you are just concatenating 2, then you are using the size, maximum size 10 to the power
10 to the power 5, just 5, right?
No, you are doubling that.
Yeah, so how much is it going to be?
So it's going to be 10 to the power of 10.
5.
Yeah.
10.
No, 2 into 10, no.
2 into 10 to the power. Yeah, 2 into 10 to the power 5. So that will.
It should be okay, because I think whatever they have explained, if you implement exactly, it works.
Yeah, I mean, it depends what constraint they are actually have in their online judge.
No, but I think this is the constraint about the input array. They don't ask you to, with your calculation, they don't ask you to stick with it.
Yeah, so that's why, I mean, the constraint are given that, I mean, you should think hard around and around that. So that's the purpose only giving these constraints.
So yeah, okay. So has anyone implemented who is a working code?
Yeah,
I think
I'm interested. That Sasank, please share when you actually submit and it actually accept that.
Sure. I'll check it. I'll submit it after some time.
Yeah. If somebody wants to see the working code, I have the code on the lines we were just going through about the prefix and suffix.
Yeah, can you share?
Yeah, you
Yes,
can go
please.
there. Yeah, no problem. Yeah, we lost you in middle. Sorry.
Yeah.
Yeah,
Exactly.
no, that's my bad. My internet is flaky these days, it seems.
Oh, it's okay. It's for
So
everybody.
I think we got the idea clearly. That is, oh, I am sharing a different screen. Sorry.
Yeah.
Let me know when you folks can see.
Yeah.
Could you make the font a little bigger, Blumi?
So you are able to see the lead code screen, right?
Yes.
Yeah.
The K-Concatenation Maximum. Okay.
Okay, yeah, because I'm getting this pop-up on a different screen, so getting confused if this is the right screen. Okay, so it's a very much same concept, that is the prefix sum and the suffix sum. I just call it a maximum sum from start and maximum sum from end. So first of all, the base cases, and if I'm just checking if k is equal to 1, then the answer is straightforward. It's the maximum subarray, and I'll return from there. If that is not the case, then if k is equal to 2, then I have the option of concatenating the array and take the uh, end of the first array and start of the second array, and see if that total is more than the maximum subarray of one individual array, and that becomes my answer. Otherwise, the answer remains the maximum subarray in the case of k equal to 2. Now, if k is more than 2, then I have the intermediate arrays I can count and increase my sum. So in that case, I take the total sum. And if the total sum is greater than 0, then I have the best of all the scenarios. That is, I can include the maximum from start, maximum from end, and then all the middle elements, all the total sum of middles. So that's what I'm doing here. So sum middle, and then maximum from start, maximum from end, because that is the biggest possible output I can get. But if my sum is not greater than 0, so this should be just an else case, but I was being a little bit, I was experimenting a little bit there. So this was the case which we were going through, and we were going back and forth as well. That is, I'll count the maximum sum from start and maximum sum from end. That is to give the first two arrays a chance to provide me maximum. If they can provide me the maximum, then it becomes my sum. Otherwise, the maximum subarray becomes my sum. And that is all. So these are all the helper methods I have written just to make things more explicit. Is this
So
clear?
where are you calculating the maximum subarray?
Here. I just calculated once.
The public
So here
long
this
max.
is the, yeah.
Okay.
It just goes through the array once and computes the maximum subarray.
Oh, you are just adding all the elements there. Okay.
In this one, I am resetting if I'm getting less than 0.
Oh,
And
so you're following the
basically,
Pradesh
I'm just
algorithm,
trying
yeah.
to find the. Actually, I'm not familiar with that algorithm, so I don't know whether I'm really doing that or not.
It's the same algorithm.
It's exactly the same, yeah.
Yeah.
Okay.
I think it got accepted. That variable error I was getting. Okay, continue.
Okay, cool.
Yeah.
So yeah, these are just the, so total sum is very plain to summing up all the elements, and sum from the end is basically you start from the end and you see that what is the maximum you can get without dropping anything. And same thing for the sum from start.
So the runtime complexity will be big of n?
For Kadani, it will be
Yes.
order of n. And for the remaining, I think it will be
Yeah, it's
It is going to be
offhand.
big offhand because I am just going through the array multiple times, but yeah, just 4 times I am going around the array. And here it is just a simple if-else ladder. There is no loops here. And I took my intuition from the problem we solved yesterday about that sorting problem which Shashank went through, in which we did not really reverse the arrays and then resorted them and things like that, right? We had this constraint which was given, which was making things more explicit that this is supposed to happen. And on those lines, if you look at it, right, you don't really have to expand the array to find the maximum subarray. There are some constraints. If you just put them into the practice here, it will just compute the sum with those edge cases and conditions.
What is the, can we see the, how long it take?
Mine,
when you submit the code? It seems like.
Yeah, sure.
If it's just if else, I believe that is
this
just
one was with system out statement, but this is without that. So
mine took 336 milliseconds.
I think that time depends on individual language, but I think the big O of n is the execution time.
Yeah.
Yeah, that's good.
Yeah, and see, there is always an optimization I could make here, right? That is, I can make a class variable and compute the prefix, suffix, and maximum in just single loop. Just wanted to keep things clear. So that's why I'm going through the array 4 times.
So I think this is the good way of doing it, at least the interview perspective.
And I think it's easy to actually handle during the interview when you have a break up the code, and you don't need to worry about that.
The style optimization can be done later. That's true.
Yeah, the idea pretty, clear and good, but in the interview, I don't know if I have enough time to write, this long code.
Yeah. But at least you could write the.
So in my previous interviews, right? What I have.
Go ahead. Sorry.
Yeah, so in my previous interviews, I follow this approach, and what I generally do is that if that method is not really the core of the algorithm, then I would just put a box there and I'll say, if time permits, I'll come back to it, because I would like to follow, or rather spend more of my time on the actual algorithm, which is this part.
That actually makes sense, yeah. So in that case, you have enough time to focus on main algorithm.
Yeah, and see, it at the end of the day, it also shows that you can compartmentalize things, and unit testing and everything of each unit becomes easier if you are putting everything inside one method. Then if your maximum subarray or prefix or suffix method has a bug, it becomes hard to find as well.
True.
I'm just like giving some ideas to explain to the interviewers, like how you can get around this and maybe even show this in a better light.
Yeah, that's right.
Yeah, true. Actually, I was reading an article somewhere, and I forgot, actually, I missed that. So that was about how actually the interviewer actually collect the data point. So if the question is really, looks like lengthy in terms of the you have to write lots of code and you break the functionality like a small function, that actually give you an advantage because you are actually writing a easy to maintainable code.
Yeah. That makes
sense.
sense.
So interviewer is not just evaluating you just from the algo point of view. If the question is just about the algorithm, so definitely, for that question, the coding will be small, but they are just trying to check some skill or some logic around that. But if it looks like simple and straightforward, trivial writing, so might be they are looking for how you actually write easy to maintainable code, and other how do you write design your code in a way so that refactor your code.
Yeah. Modularization and all those stuff. Yeah. Yeah. That's
Yes. So
Yep.
based on the problem, we had to, if someone goes in the interview, you have to consider all these things. Okay, if this problem is lengthy, then definitely what they may be looking for.
Yeah. Hey, Bomik, someone is asking in the chat. I think it's Emily. She wants you to share the code on the Slack.
I saw this code is very concise, so, but I can't understand and remember everything at this time. So I asked if the Mimic can share the code on the Slack.
Yeah, sure.
I don't know if it's possible.
Okay,
I appreciate it.
No worries. I'll just post it on that question thread.
Yeah.
Just share the you saved it somewhere online and just share the link.
I think we're going to have the video recording also, right? Tomorrow.
Yeah, we'll have that.
Yeah, that's true. Video recording will be there.
Okay.
Okay.
Yeah, I'm not familiar with Slack. I'll. So how do you guys usually put this online and share the link?
So generally, what I do, actually, sometimes lead code has that what they call it debug session or something, that
playground.
Playground.
Yeah.
But for some problem, they don't have it enabled. So for those problem, what I do, I just copy the code from here and use some online code sharing. Idiom, or one is that the Pastebin.
Pastebin.
So you can use Pastebin, and it generate you just save it, and it generates a URL and just share that URL.
Got it. Cool.
Yeah.
Thank you.
Yeah, no problem.
Thanks.
Yeah.
Thank you.
So, want to share anything, or should we stop the recording?
I'll stop sharing now.
Yeah. Thank you.
Let me stop recording.
Thanks, guys.